weeks ago for you guys to print out. So hopefully you have it. It'll make it going along a lot easier. There's 50 questions, so the session's 2 hours, so I'm assuming like 25 we'll get through in the first hour and then 25 in the next. We'll do like a 5 to 10 minute break halfway through, just so you guys can like recuperate, and yeah. Okay. And just let me know if you have any questions, or before we get started, does anybody have any questions? All right. Okay, so for the first question, it says, solve the following to the correct number of sig figs with the correct units. All right, so on the top we have multiplication, and then on the bottom we have addition, and then ultimately we're going to be dividing. So we need to know our significant figure rules for addition, division, and multiplication. So in terms of multiplication, your rule is going to be to multiply is the least number of significant figures. So that means when you multiply the numbers, you're going to look for the one that has the lowest amount of sig figs. So in our in the top numerator, you see we have 0.103, so that has 3 sig figs. 2.074 has 4, and 3.9 has 2. So our final answer should have a total of 2 significant figures for the numerator. And then when we multiply that, we're going to go ahead and get 8.331258. So that's our numerator, and then we're going to have 2 sig figs. So just go ahead and underline the ones that are significant. For the bottom, we're going to be adding. The rule for addition is going to be the least number of decimal places. So we can see here that our lowest amount of decimal places is going to be from the 12.46, since it has 2 and the other one has 3. Therefore, our final answer should have a total number of 4 significant figures, because you follow whatever the rule is for that number. So you got 17.238, and these numbers are significant. Finally, you have to divide, and then the rule for division is the same thing as multiplication. And then you get a final answer of 0.4830769, and then we follow our rule, so it's going to be the least number of sig figs. This one has 2 sig figs, this one has 4, therefore our final answer should have 2 significant figures, so we have a final answer of 0.48. For our units, well, I mean, clearly you see that 0.48 is only an A, but our unit should be, when you multiply centimeters, it'll become centimeters cubed, and then you're dividing by centimeters, and then you get a final of centimeters squared. So 0.48, therefore our answer is A. Does that make sense? All right. All right, so moving on to number 2. So it reads, all of the following are examples of physical properties except. So make sure that you guys know the difference between a physical property and a chemical property. This goes back to chapter 1. Based off of the answer choices, what do you guys think the answer is? B? E? Does anyone agree or disagree? All right. right, so the answer for this one is actually B. And that is because when metal forms a basic oxide, it's undergoing a reaction. If you guys recall, like when we had like iron and it would be oxidized, or when it's rusted, it's the same concept. So B is going to be a chemical change, or has a chemical property. All of the other ones are just physical, like things that you can observe. Being the color change in brown, that's obviously you can view that. Something being malleable or ductile, that's just a property that you can like feel and observe. A gas at room temperature, I mean, like you can't see it, but you can see something go from like solid to liquid to gas. And then the solubility is just an intrinsic factor of something, and it's not affected or changed when it goes from one state to another. Therefore, the answer would be B. Okay. All right, so question 3 reads, which of the following is a chemical property of isopropyl alcohol? Anyone have a guess? C? Does anyone agree or disagree? Agree? Yes, C is correct. So you guys haven't taken organic yet, so I mean, I don't expect you to know what an ester is. So that would be a good, that would like if you weren't sure, you should probably pick the one that you've never heard of before. Just like test taking tip. But yeah, so the other, all A, B, C, and E are all properties of alcohol. And an ester, you guys learned that alcohols have an OH group, and an ester is actually an O bonded to two other groups. So the R groups could represent anything else. So that's not present in an alcohol, and if it was, then it wouldn't be just considered an alcohol, it'd be considered like something else. Therefore, C is incorrect. Anybody have any questions on that? Okay. All right. So number 4 reads, select the physical change from the list below. C, does anybody disagree? Yeah. C is correct. When something goes from a liquid to solid to gas, you can observe that. Therefore, it is a physical change, and it doesn't change any of the properties of the element or the compound that's undergoing the change. Therefore, C would be the answer. When you burn something, rust, tarnishes is like applying some type of like chemical change as well to alter something. The composition of it is going to change. Therefore, those would all be considered chemical. Anybody have any questions on those? Okay. Okay. So 5 reads, which of the following observations are examples of chemical changes in aluminum? So I'll give you guys a little bit time to think about that. So you think it's B? B? Does everybody agree with that? Yeah, that's correct. So when aluminum reacts with acid, it's going to form hydrogen gas. That's definitely a chemical reaction occurring. Melting is physical. It doesn't change the composition. So the mass of something is just an intrinsic property of it that cannot be changed. It's going to have the same mass. And then something being a good conductor or insulator, that's also a physical property of it. So therefore, 1 is going to be the only chemical change. Does anybody have any questions on that one? Okay. All right, so 6 says, select the element from the step below that is a metalloid. So what do you guys think? I mean, for this one, all you need to know is, well, you need your periodic table, and then there's 7 metalloids. And they're kind of like in a stepwise fashion, starting from boron, going to silicon, goes down to germanium, then goes to arsenic, goes down to antimony, then to tellurium, and then polonium. So just remember those 7, and then this really shouldn't be a trick question. So the answer for this one is C. Make sure you know which ones are your metals, which ones are your nonmetals. Nonmetals are on the right side of the periodic table, metals are on the left, transition metals are in the middle. Yeah, not too difficult. Anybody have any questions on that? Okay. All right, so number 7 reads, which of the following statements are correct? So I'll give you guys a second to read that. B, does anybody disagree? Yeah, B is correct. So so number 2 is the only one that's correct, because that's just a property of the nucleus. All of the atoms are concentrated within the nucleus. The equal numbers of protons and neutrons for number 3 is incorrect due to isotopes. Isotopes is a differing number in neutrons. And then 1 is incorrect as well because the electron and the proton do not have the same mass. The proton is significantly larger than the electron, so that's why that one would be incorrect. But they do have opposite charges. Anybody have any questions on that one? All right. Okay, number 8 says, a 3.6 gram sample of lithium contains how many atoms of lithium? All right, so this is basically a conversion problem. So what conversion factors do you guys think we're going to need? Yes, and what else? Do we need anything else? We need to go from grams to moles. Yeah. So basically when you set this up, you start off with 3.6 grams of lithium multiplied by the molar mass of lithium and the molar mass of lithium can be found on your periodic table. Make sure when you guys are doing problems like this, use the whole number that's on the periodic table. Don't prematurely round. Make sure your units cross out, and you should get a final answer of C. Sorry if my handwriting is sloppy. Alright, does anybody have any questions on that one? Should be pretty straightforward at this point, but definitely a problem that I would expect. All right, so number 9, how many protons, neutrons, and electrons are in 18O? I know that's a little difficult to see. So it's 18O. All right, so this is written in a very specific way. The way that it's written is shown, I think it's in chapter 2. So basically, this number up here represents the atomic number. I'm sorry. Yeah, I had a feeling that was wrong. Atomic mass. And your atomic mass is going to be your number of protons plus neutrons. So in order to find the number of protons, we have to just look at the periodic table. The number of protons does not change in an atom no matter what. So when you go to the periodic table, oxygen has 8 as their atomic number. Therefore, the number of protons is going to be 8. In order to find the number of neutrons, all you have to do is subtract. So 18 minus 8 is going to give you 10. And then for the number of electrons, since this atom has no charge applied to it, you can assume that the number of electrons is the same as the number of protons because it's charge neutral. Therefore, it's going to have 8 electrons. Therefore, our answer for this one is going to be D. Does this make sense, everyone? Yeah. Okay. All right, so number 10, classify each of the following as a metal, metalloid, or nonmetal. So again, for this one, all we have to do is look at the periodic table. So when you look at the periodic table, carbon is going to be what? It's on the right side, nonmetal. Silicone, metalloid, yeah, that's one of the step ones. And then tin, metal, yeah. All right, so therefore our answer for 10 is going to be B. All right. Number 11, you have 0.330 moles of each of the following elements. Which sample has the largest mass? So the simplest way to do this, you could just go ahead and multiply all of them and convert them to grams using the molar mass. But it's just really testing to see if you understand a concept. Since the number of moles is remaining the same and you're going to be multiplying it by the molar mass that can be found on the periodic table for each element, it's just basically understanding if you get that as the mass gets larger, or as the molecular weight gets larger, the atom's going to have more. So essentially you're just looking for which of the following elements has the largest molecular weight according to the periodic table. So based off of that, 11 would be E. Anybody have any questions on that one? Okay. Okay, so So 12 reads, benzene has a molecular formula of C6H6, and the structural formula is the shape of a hexagon. What is the empirical formula of benzene? So when you guys learned about empirical and molecular formulas, the empirical formula what version of it is it compared to the molecular formula? When you're relating the empirical and molecular formula, how are they related? Yeah, so like one is the simplified version of the other. So when you're finding the molecular or empirical formula, the important thing to note is that your subscripts have to be in whole numbers, right? So this one is pretty simple. So C6H6, so what common factor will go into both of these? 6. Yeah, so you just divide by 6. So your empirical formula is going to be CHB. All right. Anybody have any questions on that? Not too difficult. All right, so 13 reads, what is the correct formula for an ionic compound that contains manganese 3 ions and carbonate ions? So when naming, the important thing to know is what the charges are, and basically at that point you just interchange them to find the subscripts. So for manganese, it tells you have manganese 3, so therefore you're going to have Mn3+. Then you're going to go to carbonate. Carbonate is a polyatomic, it's CO3, and it has a charge of 2 negative. You're going to interchange those. So your final answer is going to be Mn2, CO3, 3. Therefore, D is the final answer. Anybody have any questions on that? All right. All right, so 14, what is the formula for the compound which has the name tetraphosphorus decasulfide? So when you're naming two covalently bonded nonmetals, you just have to know the prefixes and basically the element, which can be found in the periodic table as well if you're unsure of the symbol. So we have phosphorus and we have sulfur. And our prefix for phosphorus is tetra, and tetra is 4. So we have P4. And decasulfide, deca is a prefix for 10. So our final answer is going to be E. For all of the prefixes, so you're going to have mono for 1, di for 2, tri for 3, penta, hexa, and no. For mono, just know we never really say mono. You just say the element by itself. So you wouldn't say monophosphorus, you would just say phosphorus. But I'm just writing it there so you guys at least know. So yeah, those are not too bad. Just make sure you are aware of the prefixes. Anybody have any questions on that one? Okay. Okay, so 15 is another naming one, but it's just going a little step further to see if you remember your polyatomic ions. So what is the formula for ammonium nitrate? Ammonium is NH4, and it has a plus sign. Nitrate is NO3, and it's negative. You interchange those signs, and then you get NH4, NO3. If it's just one, you do not have to write that. Yeah, so therefore B is the answer choice. So just make sure you guys remember all of your polyatomic ions, common ones, so PO4, phosphate, sulfate, nitrate. I think he gave you a list of which ones he wanted you to specifically know on, like, in your last class. No? I'm pretty sure he did. He specifically stated which ones. I think you have to know the chlorates, like if it's like perchlorate, hypochlorite, like know all of those. If the number of oxygen changes, how does the name change? These three, and I think ammonium. So yeah. But I mean, safe bet is to just know all, but I'm pretty sure he gave you a list. Does anybody have any questions on that? All right. 16. A hydrocarbon has a molecular formula of C2H6. What is its name? So first of all, what are hydrocarbons? Hydrogen and carbon, and like, what else do we know about them? Can't hear you. They're organic, right? So this is going to be using the rules for naming organic compounds. So therefore, C2H6 is going to be ethane. And then the prefix for naming organic compounds has to do with the number of carbons. So just make sure you guys remember the prefixes. So you have methane, which would be for 1. Ethane is for 2. Pro is 3. Butane is 4. And I think after that point, it pretty much matches the same as your regular prefixes. Pentane, hexane, heptane, octane, nonane, and decane. So those are the same. These ones are just different. So just make sure you know the first 4. Yeah. Anybody have any questions on that? Okay. Ane is for single bonds. I have a question dealing with that later on. So ANE, you have ENE and YNE. ANE is for single bonds. ENE is for double bonds, and YNE is for triple bonds. And if it did have a double or triple bond, he would either show you the compound drawn out, or he would write it in the formula, so you would see it. Like, he's not expecting you guys to know how to draw organic compounds. All right. 17. If tin metal lost 2 electrons, what is the charge in the resulting species that is formed? So this one's pretty straightforward. If you lose electrons, your atom becomes more positive. So the answer for this one is D. All right. 18. How many moles of hydrogen atoms are in 1 mole of the following compound? So we have C2H5OCH3. So when they're asking for the number, how many moles of hydrogen atoms, they're just basically asking you how many hydrogens are in your compound. You have 5 and 3, so your total is going to be 8. All right. 19. What is the molecular formula for an ionic compound that contains magnesium ions and fluoride ions? So magnesium is going to have a charge of 2 plus. They're in group 2, and fluorine is in the second to last group, so it has a charge of -1. So you just interchange those, so you get MgF2, which is D. Any questions on that? Okay. All right, so so now we have some math. When 30 grams of benzene reacts with 65 grams of bromine, 42.3 grams of bromobenzenes is obtained. What is the percent yield of bromobenzene? And then it gives you the molar mass. So this problem is basically dealing with theoretical yield, percent yield, all of that good stuff. So in order to calculate this, you first have to calculate which one is the limiting reactant, because that's going to tell you how much you can form theoretically. Because we already have the actual yield is given to us. It's 42.3. And our formula for percent yield is actual over theoretical times 100. Right? So we already have the theoretical, we already have the actual, so we just want to derive the theoretical. All right, so we're going to start off with 30 grams of benzene. We're going to convert that into grams of benzene to moles of benzene. And you want to find out how much of the product we're going to form. So we're going to go from moles of benzene to moles of bromobenzene. So before you begin problems like this, just make sure that your equation is balanced. So coming up here, I have 6 carbons, 6 carbons. I have 6 hydrogens, I have 5 and 1, 6 hydrogens, and I have 2 bromines and 2 bromines. So I'm balanced. So my ratio here is going to be 1 to 1. And the molar mass of benzene is, I have it written down, 78.11. He would either give you this on the test, or he would give you the molecular formula of benzene so you could calculate it yourself. So when you multiply this out, you're going to get 0.384 moles of bromobenzene. So that's saying from 30 grams of benzene, that's how much of the product I can form. Now I have to calculate for bromine how much product I can form. So I start off with 65 grams of bromine. I'm going to convert that with use of the molecular weight from the periodic table. The molar mass is 79.904. I use the periodic table online, so you guys might have a different one on the test, so the numbers might be a little different. Again, we're going to go to bromobenzene. Yeah, sorry. All right, and then when I multiply that out, I get 0.813 moles of bromobenzene. Also, just make sure your units cross out. All right. So, based off of our 2 answers, which one would you guys say is the limiting reactant? Benzene? Yeah. So it's going to be benzene, because benzene is going to form the least amount of bromobenzene. So therefore, it's going to get used up in the reaction earlier. So it limits how much product can be formed. All right, so now I have my moles of bromobenzene that can be formed. You have to keep this number. So essentially you calculate both to find out which one's the limiting reactant, and then you have to keep the lowest one in order to calculate your theoretical yield. So you could do this in two ways and technically get the right answer. So you have 42.3 grams of bromobenzene, and he gives you the molecular mass, or the molar mass of it. You can go ahead and convert 42.3 to moles and use that conversion to find your percent yield. But I did it by converting the bromobenzene to grams, because I'm already in grams for the actual yield. So you go 0.384 moles of bromobenzene times 1 mole of bromobenzene, 157 grams per mole, and then you get 60.288 grams. So we just went ahead and calculated the theoretical yield. So now we have both components of our formula. So I'm going to come down here and I'm going to plug everything in. So my actual yield, which is total in my problem, is 42.3 grams of bromobenzene. I just calculated that we have 60.288. That's how much our experiment can actually form. I'm going to multiply by 100%, and I get a final answer of 70.16%, which is more or less A. Does anybody have any questions on that one? Yeah, so definitely expect a problem like this on the test. He could ask it in multiple ways. Yeah. Wouldn't it be what? No, because you still only have 1 mole of it. It's 1 mole of Br2, it's diatomic, so that's how it naturally occurs. So it wouldn't be 2. I'm sorry, what? For right here. Yes, you're correct. Okay, so we have Br2, so our molar mass, so it would have to be times 2. Luckily for us, technically it would still be larger, it'd just be an even bigger amount, but yes, you're correct, it would have to be for Br2. So it would be like around 160. Yeah, my apologies for that. All right. Any other questions? Okay. All right. All right, so this question reads, how many liters of 0.110 molar NaOH solution contains 0.163 moles of NaOH? So basically, you just have to use the molarity formula. So for that, it's going to be big M equals moles over liter. So in our problem, we're given big M, so we have 0.10 molar equals, and we're given the number of moles, 163, and we are trying to find out how many liters we have. So we're going to have 0.110 multiplied by x is going to equal 163. You divide, and then you get x equals 1.48 liters. So B would be the answer. Does anybody have any questions on that one? Okay. All right. So 22 reads, that should be choose, sorry, it says chose. Okay, so choose the compound that is insoluble in water. So this question, honestly, all you have to know is your solubility rules. There's like a table that should be in your textbook. I'm not sure what page it is, but definitely make sure you guys know those rules. I have like several questions that are dealing with them. But the answer for 22 is A, and that has to do with carbonate. The rule for CO3, all carbonates are insoluble, and I think there might be some exceptions. Yeah, they're insoluble with the exception of Na plus, potassium, and ammonium. So yeah, just make sure you guys know all of your rules and your solubility rules, and know the exceptions as well. Any questions on that? All right. Okay, so 23. Write the correct formula of the insoluble product, or precipitate, which forms in the reaction between aqueous sodium hydroxide and iron 3 nitrate. So in our reaction, we're going to have NaOH plus FeNO3, and we basically, when you have a reaction like this, they basically interchange. So you're going to have NaNO3 plus FeOH. And it's basically just making sure you know what your solubility rules are. So based off of the rules, the answer is going to be B. And that just basically has to deal with the rule for hydroxides. So for hydroxides, they are all insoluble with the exception of Na plus, K plus, and then there's some that are slightly soluble, but I don't think Dr. X is going to go as far as to like make you guys know all of that. But just know the exceptions. The exceptions typically have to do with group 1, group 2 of the periodic table. So if when in doubt, I mean, kind of remember that rule. But yeah. So hopefully by doing these problems right now, it'll like kind of stick in your head which ones are insoluble, which ones are soluble. It's more important also to know which ones are insoluble. So if you want to like go ahead and like memorize that, like usually you'll deal with that more in problems, especially for like net ionic equation and spectator ions and all of that jazz. Anybody have any questions on this one? All right. 24, what is the name of the following compound? So going back to the other problem we did, when we're naming organic compounds, we need to know how many carbons we have to know our prefix. So we have 3 carbons, so our prefix is going to be pro. So we can automatically eliminate D and E. And then we clearly see that we have a triple bond, so our ending should be YNE, right? So the answer choice for this one is going to be B. Not too bad. Anybody have any questions? All right. 25. All of the compounds are examples of strong electrolytes except all right, so for 25, your answer is going to be C. So for your strong electrolytes, you want to know that they're going to be strong acids, strong bases, ionic compounds, and salts. So looking at A, LiOH, that's going to be a strong base. HCl is a strong acid, NaBr is a salt, and Kf is a salt as well, and they're both ionic compounds. So therefore, C is going to be the only one that doesn't fit any of these requirements. That's actually acetic acid, which is a weak acid. Anybody have any questions on that? Yeah, I think there's also a table in your textbook that lists like the strong electrolytes going down to the weak. So if you guys want to like just look at that, I mean, you don't have to memorize the list, but just memorize, like, understand the characteristics. And you definitely want to know what your strong acids and your strong bases are. Yeah. All right. All right, so we'll just do 26 and then we can take like a short break. Okay, so calculate the molarity of a solution by dissolving 2.39 grams of zinc chloride in a total of 150 milliliters of solution. So for this question, they're basically using the molarity formula. So you need big M equals moles over liter. And then you just start off in grams, but they give you the molecular weight. This could also be calculated from the periodic table. So now you just need to solve. So you start off with 2.39 grams of zinc chloride. Grams of zinc chloride is going to be 136.3 in 1 mole. And then you can just go ahead and do another conversion factor. You can put 1 in the numerator and the denominator. So for moles, big M, you need to make sure that you're in liters, moles and liters. So we are in milliliters, so we have to convert that. So I just went ahead and converted that myself, and then you can multiply across. So grams are going to cancel, and you're going to be left with moles over liters, which is the same thing as big M. So when you multiply everything out, you get 0.1168 M zinc chloride, which is the same thing as 0.12 rounded. So the answer choice for this one would be E. Anybody have any question on this? Oh. All right. Okay, so we can have a break. We'll reconvene at 10. You guys can go get coffee, whatever. If anybody didn't get to write anything down, you can come take pictures of these. And at the end, you can take pictures of them too. Yeah. Okay. So we will continue with number 27. Okay, so 27 reads, salts may be either strong or weak electrolytes. Which of the following compounds is considered to be a salt? So going back to, this is similar to like the strong electrolyte question, but it's just basically seeing if you understand the concept of a salt. So a salt's going to be an ionic compound. And so that's going to be a metal plus a nonmetal. And it typically results from an acid-base reaction. However, in this case, we don't have a reaction to go off of, but just based off of this rule, the answer choice for 27 is going to be C. Pb is a metal and Cl2 is a nonmetal, so therefore that's an ionic compound, and the rest don't really fit that category. Anybody have a question on that? All right. Which of the following compounds will be considered most soluble in water? So we have NaOH, MgOH2, C2OH2, CuOH, and FeOH3. So this one's basically just testing to see if you guys remember your solubility rules. And so the solubility rule for this one is for OH, and it's hydroxides are insoluble except for Na plus and K plus. So based off of that, the only one that's going to be soluble then is D. Anybody have any questions on that one? All right. So 29, which of the following ions will always be a spectator ion in a precipitation reaction? So spectator ions are typically consumed in the reaction. So when you have multiple reactions occurring, it's going to be in the product of one and the reactant of another. So it'll cross out and therefore not be in the final product. Your final product for these types of reactions should be two compounds which will form an insoluble product which will precipitate. So therefore it's just asking to see which one is soluble, and the answer for 29 would be C. And that has to do with the solubility rules as well. All nitrates are soluble. And let me see if there are any exceptions. No, there are no exceptions. So all nitrates are always soluble. Any questions on this one? All right. So 30, determine the oxidation state of chromium in Cr2O3. All right, so when dealing with oxidation states, basically you just need to use the rules. There's like specific rules laid out that are in your textbook. And you just basically have to know that they go in order. So rule 2 will take precedence over rule 3, and so on and so forth. So you wouldn't follow rule 7 over rule 3 if both apply to your compound. So for this one, the rule that we're going to use first is for oxygen. So the rule says that oxygen typically has a charge of -2, unless like special cases. This is not one of those, so the charge on oxygen is going to be -2. We need to figure out our charge on chromium, so we're basically just going to set up an equation. So we have 2 chromiums, so I'm going to call that X. And then you're going to add it to oxygen, so you have 3 oxygens multiplied by a charge of -2 is going to equal 0. We know it's 0 because if there was a charge on this element, it would be written in this upper corner. There's nothing there, therefore I know my charge is 0. So when I solve for this, I get X equals +3. So the answer choice for this one would be D. Anybody have any questions on this one? Okay. 31. Which substance in the reaction given below is the oxidizing agent? So basically for this, you're just going to go through and find the oxidation states of the products plus reactants. So I'm just going to write it a little bit bigger. So for Cl, that follows the rule that states that atoms in their elemental form are just going to be 0. Chlorine it's a diatomic element, so it naturally occurs as Cl2. So that's going to stay at 0. Na and I, you're going to follow the rules for those, and they just take on the charge that is derived from their periodic table. The charge on I is typically -1, and sodium is going to be a +1. Coming over to the products, I2 is also diatomics. The natural charge is just going to be 0. Na is going to be +1, and Cl is going to be -1. And the rules for this is the same rules that we follow for these. So looking at our equation, chlorine goes from 0 to -1. Therefore, it gains an electron. So our prefixes that we can use are Leo goes ger or oil rig. I prefer this one. So gain in electrons is a reduction. And then Na stays the same. So it's neither oxidized nor reduced. And then I goes from -1 to +1. So therefore it gains it loses electrons, so it is oxidized. So with respect to the oxidizing agent, the oxidizing and reducing agents are basically the opposite. So once you find out which element is reduced, that's going to be your oxidizing agent. Once you find out which element is oxidized, that's your reducing agent. Therefore, based off of this, Cl2 is going to be the oxidizing agent, and NaI is your reducing agent. And it has to be the entire compound. So say, for example, they were asking what's the reducing agent, and you had NaI, then you had Na, then you had I, you would choose NaI. It's the entire compound, right? Does that make sense? All right, so based off of that, our answer choice is B. Anybody have any questions on that one? Yeah. I. So I goes from -1 to +1. right? Or I'm sorry, I wrote my arrows wrong. Thank you. There we go. Yeah, so it's I. I is going from -1 to 0. Na stays the same. I don't know why I drew my arrow over there. But it's neither being oxidized nor reduced. However, the reducing agent is going to be the entire compound that contains the I in it. All right, anybody have any questions on that? Okay. Okay, so 32 reads, which of the following are oxidation reduction reactions? And you're given 3, and you just have to basically find that out. So quickly, like going through them, we can eliminate 2, because if you guys look, it doesn't even have like all of the reactants and products listed. So like K starts off, and then it's not present in the product. So that one would automatically be eliminated. So we can go ahead and eliminate C, B, and E. So we're between A and D. So looking at 3, CaCO3 breaks down into CO2 and CaO. You can go ahead and solve out for the oxidation states, but typically when you see that you have a compound that breaks into 2, it's usually, how do you say? It's usually not an oxidation reaction because you have your polyatomic being broken down into 2 typically. If it was a oxidation reduction reaction, you would have CO3. It would react with something else, and then basically the carbonate would go to another metal. So based off of that, 3 can be eliminated as well. And if you guys look at 1, that follows the same rules. Zinc basically switches with copper and takes on the sulfate. So you have an atom that's starting in elemental form, so it's 0, but when it gets paired with sulfate, it's going to take on a charge. So it's going to take on a +2 charge. So therefore, the answer for this one would be A. All right. 33. Select the strong acid from the step below. A strong acid is also a strong electrolyte. So for this one, you just basically have to know what your strong acids are. There's like specific, I think there's 6 of them. So the answer choice for this one is B. And all of your strong acids, you have HCl, HBr, HI, H2SO4, HClO, I think it's 3. Let's see. Yeah. HClO3, HClO4, and HNO3. So these are all of the strong acids that you guys should just kind of memorize. And if you look at the rest, they're all bases. With the exception of C, that's going to be acetic acid, which is a weak acid. Any questions on this one? Okay. 34. Predict the identity of the precipitate that forms when aqueous solutions of BaCl2 and C2SO4 are mixed. So this one is also dealing with your solubility rules. So we have BaCl2 plus K2SO4. We're going to switch them, so we're going to have barium with sulfate. And then we're going to have potassium chloride. Potassium is in group 1, chloride is in group 1 as well. So their subscripts are going to be that. Sulfate has a charge of -2, and barium has a charge of 2, so their products, they're going to cancel out. So Ba2SO42 is the same thing as BaSO4. And it's just checking to see which one. You don't have to worry about balancing the equation for this one. It just wants you to know your solubility rules. And this one deals with sulfate. And it's sulfates. All sulfates are soluble except Ba2 plus, Pb, Ca, and Sr. So this fits one of our exceptions. Therefore, it's going to become a precipitate because it's insoluble, so it's in the solid form. Okay, any questions on that one? Okay, so this one's pretty easy, just a definition. Blank is the smallest identifiable unit of an element. What's the answer to this one? Yeah. I'm sorry, what? Oh, the answer for the last one is C. Yeah, sorry about that. Okay, so what is the smallest identifiable unit of an element? So that's just going to be an atom. That's just like a definition from chapter 1 or 2. So yeah. Okay, so determine the number of protons, neutrons, and electrons in the following. So I'll write that a little bit larger. So we have X, we have 65, and 29. So that's we're in the specific form again. So that's going to be your atomic mass, which is your number of protons plus neutrons, and this is your atomic number, which is the number of protons. It's also equal to the number of electrons if it's charge neutral, and we have no charge in this one, so it will be charge neutral. So based off of that, we can go ahead and figure out that our number of protons is 29. So that's going to go ahead and eliminate D and A. And then our number of electrons is also 29. So that's going to go ahead and eliminate C and E. So we know our answer would be B. And just to calculate the number of neutrons, you would just do 65 minus 29, and you get 36. So not too difficult. Just make sure you know like this form and how it's written and what it means. Any questions? Okay, So the width, length, and height of a large crate is 1.22 meters, 3.22 meters, and 0.83 meters. If the box were filled with water, how much would it weigh in grams? Okay, so this question is dealing with density. So we're going to need our density formula. So D equals M over V. Our crate is getting filled with water, and your density of water, so you guys should pretty much know this by now, but it's 1 gram per milliliter. That may be given to you on the exam at the end, but you should just pretty much know the density of water. So I'll just kind of write no. Water. And then basically we're just going to be plugging in the numbers into this formula in order to calculate our mass. So some things to note: you need to know the conversion from milliliters to centimeters, so they're equal. 1 milliliter equals 1 centimeter cubed. So that's the same thing as just writing 1.0 grams per centimeter cubed. And since we have the length, width, and height, we can go ahead and calculate the volume, length times width times height, and then that will help us find our mass in grams. Just some things to note: we start off in meters, so we're going to have to convert to centimeters. So you need to know the conversion from meters to centimeters. So 1 meter equals 100 centimeters, so just make sure you guys remember that. And then I always find it's easier to convert before you start multiplying. So you have 1.22 meters is going to be 122 centimeters multiplied by 322 centimeters multiplied by 83 centimeters. And then you have your mass, and then it equals 1 grams over centimeters cubed. So when you multiply the denominator out and multiply it over here by the reciprocal to get M alone, you get M equals 3,260,572, which is the same thing as 3.3 times 10 to the 6th. So in this question also, they're testing to see if you remember your significant figures. So when solving this question, you have to go with the least amount of sig figs from your question. So you're using your rules for multiplication and division. So your rule for multiplication is the least amount of sig figs. So if you look at this one right here, when we convert, our sig figs are going to be, the least amount is 83, so it's 2. The density is a number that's given and it doesn't change, so that's not going to be used to decide what number of sig figs you get. So therefore, your final answer should have 2 significant figures. That's why the answer is going to be 3.3 as opposed to C, 3.26. Does that make sense? Any questions? Okay. Okay, so 38. The most correct answer to the following problem is, so this is also just dealing with significant figures once again. So we are starting off with, so we have 944.3 plus 45.12 minus 9.9, and then multiplied by 8.12 times 10 to the 5th. So we also, so make sure you guys remember PEMDAS, so we're going to start with our parentheses first. we're using our rules for addition and subtraction, which is the least amount of decimal places. So our least amount of decimal places, so we see that we have 3 and we have 9. So they both have 1. And I was like a little unsure of like what you do when you both of them have the rule. And I like researched it, and it followed the one that had the most numbers. So even though this one has 9, this one has 1 decimal place, this one has 1 decimal place, you have to follow the rule for that number. So typically if this was 3, this was 0.12, and this was like 9.91, you would follow 3 and then use 5, right? So that's the same in this case. You're going to use your final answer for the parentheses should have 5 decimal place or 5 numbers, if that makes sense. So when you add this or solve for this part, you get 9475.52. And your sig figs are going to be 9475.5. Then we're going to bring down the 8.12 times 10 to the 5th. And then we're going to multiply, and we get 7694122240. And then if you look, so for multiplication, the rule is going to be the one that has the least amount of sig figs. So this one has 3, and this one has 5. So our final answer should have 3 significant figures, and you basically just have to convert this number to scientific notation. So you're going to get a final answer of 7.69 times 10 to the 9th. So the answer for 38 is B. Does that make sense to everyone? Okay. Okay, so 39. Which of the following contains both ionic and covalent compounds? So when it asks for both ionic and covalent, so ionic is going to be a metal and a nonmetal. And covalent is nonmetal plus a nonmetal. So looking at our problems, you can automatically eliminate A, because that's just ionic. NO is just covalent. NAF is also ionic. D will skip. And E is covalent. So looking at this, so MgSO4. So start off with SO4, S and O, so that's a polyatomic ion. So polyatomic ions have, within them, this specific one has a covalent bond because it's sulfur and both oxygen are both nonmetals. However, it's also bonded to magnesium, and that's a metal. So therefore, it has both properties. So typically when you get a question like this, you're going to look for the one that has a polyatomic ion in it. Anybody have a question on that? Okay. All right. 40 reads, which of the following is a molecular element? And this one is just asking, there's like 7 of them that are diatomic, and then there's some that are polyatomic. So for this one, it's going to be E. So just make sure you guys memorize which ones are diatomic, polyatomic. So I2, Br2, Cl2, O2, believe nitrogen is one as well. Hold on. Hydrogen. And fluorine. So N2F2. So these are all of your diatomic ones, and then there's some polyatomics, which is going to be phosphorus, sulfur, and selenium. I don't think you guys need to know these ones. I think it's like P4, S8, and selenium is something I can't remember the number. But I don't think Dr. X required you to know that, right? Yeah. So just make sure you know these ones. Any question on that? Okay. Okay, 41. How many milliliters of 0.266 molar cesium nitrate solution are required to make 150 milliliters of 0.075 molar cesium nitrate? So this is using your M1V1 formula, so for dilution. So M1V1 equals M2V2. So we're going to calculate, we're looking for milliliters, so we're looking for V1. It could also be V2. It doesn't really matter how you place it, just as long as you're consistent. And then also note, if you're in molar, you have to be in liters. So we're going to have to convert that part. So starting off, so we have 0.266 molar times V1, which is what we're looking for, is going to equal our new molarity of 0.075 multiplied by our V2, so make sure you convert that. So 150 ml equals 0.150 liters. And then basically when V1 is going to equal 0.075 times 0.15 over 0.266, and V1 equals 42.3 liters, so the answer choice is C. I'm sorry, hold on. You had to find, your answer had to be in milliliters, so this actually did not need to be converted. So it would stay in milliliters, and let me rewrite that part. Yeah, because if you would have multiplied that, your number would have been different. So that's a good example of read the question properly, which is also a good test-taking tip. Okay, any questions on that? All right. Okay, so 42 reads, in the acid-base neutralization reaction, 48.74 milliliters of 0.5 molar potassium hydroxide reacts with 50 milliliters of sulfuric acid solution. What is the concentration of sulfuric acid? So first thing that you're going to need is you have to write out your chemical formula. So we're going to start off with potassium hydroxide, and we're reacting it with sulfuric acid. So here we have an acid-base reaction. We have a base with an acid. And when you form a reaction between an acid and a base, you form a salt and water. So we're going to have H2O, and then our salt ends up being K2SO4. Okay. Secondly, once you form your reaction, you need to make sure that it's balanced. So, looking here, I have 1 K on this side, 2 on this side, so I know I'm going to need 2 of that. And then, so I have 2 Ks. Now I know I have 1 S. Now I'm going to do my oxygen, so I have 1, 2 oxygens plus 4, so that's 6. Here I have 5. So typically you'll maneuver the one that is the smallest. So I'm going to go ahead and put a 2 there. So now I have 6 oxygens, and then now I just need to check my hydrogen. So I have 4, and then on this side I have 1, 2, 3, 4. So I'm balanced. So I added a 2 and a 2. All right. So now that I have my equation, I'm basically going to use my molarity formula to calculate the number of moles. So they tell me I have 48.74 milliliters and I have 0.5 molar. So using these, I can calculate the number of moles of potassium hydroxide. So 0.50 molar is going to equal, for this one I need to convert. So 0.04874 liters over X amount of mole. So for this one I get X equals 0.02437. And this is my moles of KOH. Now that I have my moles of KOH, I can use my reaction that I just found and the coefficients to find how much moles of H2SO4 I have. So I'm going to go ahead and multiply. So in 2 moles of KOH, I have 1 mole of H2SO4. And just to save some space, for the final answer, they want the concentration, which is measured in molarity, right? Molarity is moles over liter. I'm going to end up in moles of H2SO4, so I just have to divide by the liters, and they tell me how many liters I have of sulfuric acid. I just need to convert that. So that's going to be 50 milliliters is the same thing as 0.05 liters of H2SO4, and I can just go ahead and put a 1 up top. So when I do it, moles will cancel, and I will have moles of H2SO4 over liters of H2SO4, which is ultimately what I need for molarity. So when I solve that, and change the color, I get a final answer of 0.244. So my answer would be C. Does anybody have any questions on that? No? Okay. Yeah, so definitely remember your acid-base reaction, how to form one, and remember, just remember your molarity formula and stuff. Yeah, it's not too bad of a problem, but it's pretty involved in things that you have to remember stepwise. All right, 43. So 43 is really long, and I didn't give myself enough space to solve it, so I think I'm going to just show you guys my work that I did and then explain it. Okay. Okay. This little bit at the corner here, don't worry about that. That was for the previous problem. Okay. So initially, we start off with the problem tells us combustion analysis of 12.01 grams of tartaric acid, which contains carbon, hydrogen, and oxygen, produces a certain amount of CO2 and a certain amount of H2O. And it gives us the numbers for CO2 and H2O that we form. It wants us to find the empirical formula of tartaric acid. So when you set up your equation initially, you need to know what the formula is for a combustion reaction. So basically, in a combustion analysis problem, you're going to have either a hydrocarbon of just CH, or you're going to have CH and O is going to react with oxygen to form carbon dioxide and water. So that's labeled up here. So basically, we're trying to find X, Y, and Z, right? For our empirical formula. So that's how much we form of each compound. And then we're basically just going to use those to work backwards to find out how much we initially started with. And this is all based on the notion of conservation of mass, like mass is not lost. So the same amount that we form in our product should be in our reactant. So what you initially will start with is for CO2, that's what you're going to use to find out how much carbon you started with. So I start off with 14.08 grams of carbon dioxide, and I'm going to use the molar mass to convert to moles. Once I'm in moles, I can convert from carbon dioxide to carbon, and I find out how many moles of carbon I have, right? In order for X, Y, and Z to be found, I need those values to be in moles. So make sure that you guys do the extra step of converting to moles and don't convert it to grams and use that. You cannot plug in the value of grams of carbon into the empirical formula. All right, so now I found my value for carbon, so I'm going to circle that because that's going to be used in my final part to figure out the empirical formula. In the next part, I'm going to do the same thing except for hydrogen. So for hydrogen, I'm going to use water. So I start off with 4.32 grams of water. I use the molecular weight of water. And then make sure you have the ratio correct. There's 2 moles of hydrogen in 1 mole of water. So therefore, I get 0.4796 moles of hydrogen. I'm going to circle that one as well because that's going to be used in my final equation. So typically when you guys so the easier version of this problem would be if tartaric acid only had C and H in it, then technically you guys would just plug that in and you'd be almost done. But your oxygen is split up into 2 compounds. So we need to find out how much oxygen was in our O2 and then how much oxygen is in our tartaric acid. In order to do that, we know that we start off with 12.01 grams of tartaric acid, and we're basically going to use that value to subtract how much carbon and hydrogen we have, because we know that. We just calculated that. And then that will tell us how much oxygen is left in that compound. So what I went ahead and did was convert moles of carbon into grams of carbon. So that's how many grams of carbon I have. And then I did the same thing for hydrogen. And that's how much grams of hydrogen I have. I add those 2 values, and I get 4.325399, long number. I don't prematurely round, that's why I write out the whole thing. And that's how much carbon and hydrogen I have in tartaric acid. Using that value, I can subtract that from 12.01 to find out how much grams of oxygen I have. Is everybody okay up to this point? Yeah, I know, it's a lot of writing. If it helps, like, you could take pictures and then write it later. But yeah, okay, so now that I'm in grams of oxygen, I can go ahead and convert that to the moles of oxygen, and that's going to give me my Z value that I need, right? So using the molecular weight of oxygen, 15.99, I find that I have 0.4805 moles of oxygen in tartaric acid. That's not the total amount of oxygen, though, that I have in the reaction, because there is some that's from the O2. But I don't need that for the purpose of finding the empirical formula. So now I circle that number. So now I have my three values that I need for C, H, and O. So I know I wrote it really small down here. So I'll probably transfer over. So you have C with 0.3199, H with 0.4796, and O with 0.4805. I'll put this back in a second for those of you who didn't get to finish copying it. So this is what I end up with. So when you have your numbers like this, obviously, like, that's not the final answer. You can't have decimals. So we're going to go ahead and divide by the smallest. So divide everything by 0.3199. Once I do that, I get carbon has a subscript of 1, hydrogen has 1.5, and oxygen has 1.5, more or less. The number rounds to that. I cannot have a subscript of 1.5, though, so I'm going to go ahead and multiply that by 2, the whole compound by 2. That'll give me a whole number. So once I do that, I get C2H3O3, and then that's going to be answer choice B. All right, does that make sense to everyone? I'll give you a second to copy that. Yeah. Uh-huh. From this, that's not the molecular weight of carbon. That's how much tartaric acid we start out with, and they tell us that in the problem. It just happens to be the same number. Yeah, sorry about that. I don't know why they put it so close. But yeah, they tell us we have 12.01 grams of tartaric acid. That's where it came from. Yeah. Okay. All right, so we can move on. If anybody wants to take pictures at the end, you can go ahead and do that, just so we can hopefully try and finish everything. Okay, so 44. Okay. The mixing of which pair of reactants will result in a precipitation reaction. So this is also just testing solubility rules. And the answer choice is going to be B. Because that's going to follow the rule for, I think, carbonate. Yeah, all carbonates are insoluble, except for the exceptions. However, barium is not one of that. So when you do this reaction, you're going to get BaCO3 plus NaNO3. We learned that all of our nitrates are soluble. This is insoluble, and there are some exceptions. Barium is not one of them. The exceptions are Na, K, and ammonium. So not too bad. Okay, so for question 45, I went ahead and changed it because that question was like weirdly worded and there was an error in it, so I changed it to a Hess's law problem. So it doesn't match your what's posted. So yeah, so we'll go ahead and do this one. So for Hess's law, basically, if you guys remember, I know you guys just took your test, so this should be pretty fresh in your head still. You're going to basically manipulate the three reactions to get this final reaction. So I look up here, and I have 2 carbons plus hydrogen gas is going to give me C2H2. So I need carbon on the reactant side. So I look here, and carbon is on my reactant side in this one. However, I need 2 of them, so I know I'm going to have to multiply this one by 2. So when I multiply this whole reaction by 2, this is also going to have to get multiplied by 2. Now I'll write out my new thing. So 2 carbon plus 2 O2 is going to give me 2 CO2, and my delta H is going to be negative 787 kilojoules. So also I see I have hydrogen gas, and that needs to be on my reactant side. I look here, and hydrogen gas is on the reactant side, so I'm going to go ahead and bring that one down. So it's going to stay as H2 plus half O2 is going to give me water, and my delta H is going to stay the same. Now I see I have 2 CH2 in my product. That's going to come from reaction 1. However, it's on the wrong side. So I'm going to have to flip that one. So flip. So now I'm going to have 2 CO2 plus H2O will give me C2H2 plus 5/2O. And my delta H, when I flip it, has to change the sign. So it becomes positive 1299.5 kilojoules. So now I have to just make sure everything comes down that needs to, and everything crosses out that needs to, right? So coming here, so 2 carbon is going to come down. It does not cross off anywhere. I'll write that in a different color. 2 carbon comes down. My hydrogen needs to come down, so that comes from here. It does not cross out anywhere, so that follows. And then I need to have C2H2, which is in the product, so that follows. So I went ahead and used up everything I needed, and now I just need to make sure everything else crosses. H2O and H2O will cross out. They have to be on opposite sides in order to be crossed out. 2 oxygens. 2 oxygens on this side plus half is going to give you 2.5 oxygens. That's the same thing as 5/2 oxygens, so these are going to go ahead and cross out. Does that make sense to everyone? Okay, and then the 2 carbon dioxides will cross out with the 2 carbon dioxides from the first reaction. So basically when I do that, I just have to add my delta H's. So I'm going to have negative 787 plus negative 285.8 plus 1299.5, and you get a final answer of positive 226.7 kilojoules. And that is my final answer for delta H. Does anybody have any questions on that one? Okay. All right. 46. A 31.8 gram sample of ethane is burned in a bomb calorimeter. If the temperature rises from 25 to 62.3 degrees Celsius, determine the heat capacity of the calorimeter. So for this question, you need a few formulas. So your first formula that you need is Qcal is going to equal Ccal times delta T. Ultimately, we're trying to find Ccal, so this is what we're looking for. You also need delta E of the reaction is going to equal Q of the reaction, which equals negative Q of the bomb calorimeter. With all of this information, this is pretty much everything you need to solve the question. So I'm given 1235, so that's going to be my delta H of the reaction, and then that's per mole. So that's significant because I start off with 31.8 grams of sample, and I'm going to need to convert that to moles to find my Q per mole. So I start off with 31.8 grams of C2H5OH. I'm going to multiply that and convert it. So moles of C2H5OH is going to equal, the molecular weight is 46.07 grams. So when I solve that, I get 0.690 moles of that compound. Now that I have the moles, I can go ahead and divide that. So I'm 6.90 moles of C2H5OH. Oh, sorry. There you go. Okay, so is going to equal negative 1235 kilojoules over 1 mole. So moles will cancel, and I get a final answer of negative 852.46 kilojoules. So that is my Q. All right, so now once I have that value, I'm going to go ahead and plug it into this formula up here, because I have my delta T 25 to 62.3, and now I just calculated my Q of the reaction, which is the negative Q of cal. So I have all of the information to find C. So since Q of the reaction equals negative Q of cal, then this is going to be positive. Positive 852.46 kilojoules equals C cal times delta T, which is 62.3 minus 25. Same thing as 37.3 degrees Celsius. So C cal equals 852.46 divided by 37.3. And C cal equals 22.8 kilojoules per degree Celsius. Does that make sense to everyone? Okay. Okay, so unfortunately we're out of time. So I didn't get to do 4 of the problems. So what I'll go ahead and do is I'll post the solutions for these on the Google site. Do you guys know how to get to my Google site? Okay, so for these 4, I'm going to post the solutions for it. For the ones that I got through, I'm not going to post the solutions of how to work those, but I will post the answer key. So you guys will have that. So yeah.